Okay, if you were in class, we thoroughly discuss 3D and how the XY coordinate plane can actually be turned. And now there is a line up and down, which is the Z axis. So we have X, Y, and Z coordinates. You really won't use them until you reach Calc 3, but now we're in 3D planes, okay? Because we live in 3D. We actually don't view 3D. The lighting and with our vision, it appears as if we're in 3D. So we are, but visually we don't actually perceive it. So what happens if we are in 3D and there are 3 planes? Okay, so if you look here on the back of your notes, there are instances when 3 planes can come together at a point, okay? And there's instances where they never come together, all 3 of them at the same time. Okay, so we're going to talk about when a 3D system or 3 variable system comes together. So graphing would not be beneficial, and we talk about that in class. We actually try to graph the planes in 3D, the notes that are prior to this, but I'm not going to make you do that here. So you're just going to solve a 3 variable system using substitution elimination. We have 3 variables, not necessarily objects in 3D, or we could just have 3 missing pieces and use a system to solve. So we can use substitution or elimination. When you use substitution, you take one equation and substitute that expression into both the other equations. When you do that, it's not going to be 5x minus 3y plus z anymore. It's going to be 5x minus 3y plus x plus 5. And just like the other one, it's not going to be 2x minus 2y plus 2z anymore equals 4. You're going to replace that z with an x plus 5. So when we clean it up, we're going to get negative 4x. We're going to get negative 3y. We're going to move 5 to the other side. Here I'm going to keep it in standard form. Negative 2x minus 2y plus 2x plus 10 equals 4. The x's will cancel, and you're going to get negative 2y equals negative 6. Well, that was convenient, okay? Normally you'd have another x, y, and a number, and you'd solve that system. So when you divide by negative 2, you actually get 3. Then you're going to take that 3, substitute in here, figure out what x is, and then substitute into any equations, and you're going to figure out what z is, okay? So let's try it again on the back real quick. Substitution. Now we have an x equals and we have a y equals. If I use an x equals, it can go into this one and in this one. If I use a y equals, it could only go into this one. So it doesn't matter. I'm just going to go with x because it says take your one equation and substitute it into both. It's up to you. Either one should work. When I do that, it's not 3x plus 4z equals negative 7 anymore. The x is going to be replaced with the 4y minus 11. So it's going to become negative 12y plus 33 plus 4z equals negative 7. I like to keep it in standard form. So the y, the z, when you move the negative 33, it's negative 40. I'm kind of skipping steps. I'm going kind of quick. You can always pause and go back. And also I'm saying this because be careful. If you go this fast, you might get an error. And when you get an error in one line, it will affect the giant equation. When you substitute x into the next equation, it is no longer y equals negative 5x plus 2z plus 25. It's 4y minus 11. So it's going to be bring the y to the other side. 55 and 25 are 80. Okay, so now you replace, what you did is you took one equation, substituted into both to knock out a variable. Now we have y's and z's. If we don't have the same variables, then we didn't do something right, and there'd be no purpose in doing this. So we can get rid of the z's. If that's a positive 4, I want this one to be a negative 4, so I need to multiply by 2. I'm going to get 42y negative 4z equals 160. And I'm going to put that with negative 12y plus 4z equals negative 40. When I subtract, I'm going to get negative 30 equals 120, y equals 4. All right, if y equals 4, I can go back a step, put y in, and I'm going to get 42 times 4 minus 4z equals 160. 4 times 2 is 8, 168. Excuse me. Z equals 2. All right, if z equals 2, y equals 4, it doesn't matter which equation you use, you can plug it in to find x. So let's go back up to the top where x is. We know that x is, we don't know, y is 4, z is 2, so we want to know what x is. X equals 4 times 4 minus 11. X equals 16 minus 11. X equals 5. So that's how you're going to solve if you use substitution. Okay. Many of the word problems will be in substitution that we do coming up on Monday. Okay. Or whatever day this is, because this video might not just be for this class, it might be for another semester. The following lesson. Okay. Now that was substitution. We also have elimination. Elimination works nice when you have the variables stacked up, like normal elimination. So it says rewrite the system of 3 equations as 2 systems. All right. So I am going to look. 4s, I like that. There's a negative. It could knock that one out, knock that one out. Y's, I'd have to multiply by 6, multiply by 3 to get them all 6s. Same here. So I'm just going to look at the x's here. If I put these two together, the x's will disappear. And if I put these two together, this x will disappear. So there's one equation that you're going to use twice. So we can take 4x minus y plus 6z equals 27 and put it with the middle equation. Pause if you need. And then we're going to use that same middle equation again, and we're going to put it with the bottom equation. When I add them together, I'm going to get negative 3y plus 9z equals 48. And when I put them together over here, I'm going to get negative 8y plus 5z equals 33. Okay. With that being said, this is now a systems of equations which we're used to. We have an 8 and a 3. We have a 9 and a 5. We'd have to get a 45 or a 24. It doesn't matter. Let's make the y's a 24. So I'm going to have to multiply by 8 here to get negative 24. And I have to multiply by negative 3 here. When I multiply by 8 here, 48 times 8, 32, 384. When I multiply by 3 here, I'm going to end up getting z is 5. All right, so let's recap. Rewrite the system of 3 equations using two systems with 2 equations. So we rewrote it, boom. We rewrote it, boom. Eliminate the same variable in both the systems. We eliminated y. Using the resulting equations to write another equations of 2 systems. Solve the elimination. Oh. So we're now at z. We can go back a step. Here, 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 or here. And figure out what y is. 5, -1. And x is going to be, well, you go back to the original equation, 4x minus a -1 plus 30 equals 27. So 4x, x equals -1. Okay, the beauty of math is you can check your work. Plug it back in. All right, so that's how you complete elimination. I want you to pause the video and try this one on your own. Come back and check your work. Mm-hmm. -4x and -4x make -8x. That's where I went wrong. Okay, so now we have a 10x, an 8x, a 5, and a 4. If we can make the 5 and the 4 go to 20, let's do that. So let's multiply by 4 here, and we'll get -40x minus 20z equals -108. Let's multiply here by, if we want this to be -20, let's make this positive 20, so -5. When you add, you're going to get 0 plus 0, that's okay, equals -8. Now, if this was a true statement, it would be infinitely many solutions. But is this true? Not true. Therefore, no solution. There's no number that's going to work. It's going to look like that. Okay? So if you're frustrated because you're like, it's not working, that's why there's no solution. So Delta Math, you have problems. They are due by Sunday night.